Good morning. Here, uh, good morning, guys. Here now the topic is about heat and temperature. Okay, heat, heat and temperature. Okay, so here a first question is: a system X is neither. Okay, not either. The system, a system X is neither in thermal equilibrium with Y nor with Z. So the systems Y and Z. So what he said to be, a system X is there and a system Y and Z also there. This system X is not in equilibrium with this or either this. Okay, with these two, that is not in equilibrium. So what about these two? Okay, so that may be in thermal equilibrium. Why? Because we didn't know about these two. Okay, that means this is not in equilibrium with this, so these may be in equilibrium, so that's why this is not with this, or they may not be in equilibrium. So maybe in thermal equilibrium is a good one about these three options. Okay, and the second one, which of the curves in below figure represents the relation between Celsius and Fahrenheit temperature? Okay, Celsius and Fahrenheit temperature, you have to first know about the relationship between Fahrenheit and Celsius temperature. So F equal to 32 plus 9 by 5 into C, centigrade temperature. Okay, this is the relation. So from this relation, put the values of C and find out the F. Then you got the then you got the graph as in this way. So here A is the right option. And here, which of the following pairs may give equal numerical value of the temperature of a body? Many of us. Okay, here for suppose if D is none of the above, definitely we put the option as D only. Okay, but here is the option is A, Fahrenheit and Kelvin temperature. I posted a link in comment section. Okay, you can view that for this question. Okay, then that will be clear your doubt. Okay, so and 4, for a constant volume gas thermometer, one should fill the gas at. That means for a constant volume gas thermometer, for this question you have to know about what is volume gas thermometer first. Okay, in volume gas thermometer concept, whether you increase the temperature, okay, whether you increase the temperature, the pressure should increase in case of volume gas thermometer. So we should fill the gas at, not in low temperature and low pressure, not at high temperature and high pressure. Why? Because these two are not applicable with this. So here we have to apply the pressure, we have to fill the gas with remedy of these two. That means one is high and one is low. At that most proper option is at high temperature and a low pressure. Okay, when you fill the gas with high temperature and at low temperature, after filling the gas, it should be increases with the pressure of gas in the container should be increases with the temperature. Okay, before the filling only it increases, then the gas thermometer is not in ideal case. Okay, so that's why C is the better option. And 5, consider the following statements: the coefficient of linear expansion has dimension as per Kelvin, and the coefficient of volume expansion also has a dimension of per Kelvin. So what is the these two statements are correct or not? Okay, first you have to know about the expansion values here. Why? Because there is nothing. Okay, you can't tell about when you didn't know about this volume expansion and linear expansion. Okay, so first know about these things. What is linear expansion alpha, and what is volume expansion rho equal to 3 alpha simply. So if the alpha is per Kelvin, okay, then rho is also per Kelvin. So A and B both are correct. Okay, and the next one, next question behind this. Okay, so here are the next questions. So just wait. So metal sheet, the sixth question, what is metal sheet with a circular hole is heated, then the hole gets larger or gets smaller or remains of the same size. Okay, or remains of the same size or gets deformed, this question. Okay, metal sheet with a circular hole is heated, that means you have a metal sheet like this. Okay, so here you have a hole. So when you heated this metal sheet, definitely with temperature increases linear expansion in the body. So definitely this increases its volume expansion entirely, then definitely the circle gets larger. Okay, so is the option. And the next one, two identical rectangular strips. Yeah, here two identical rectangular strips, and that means both are at same height and same width. So one is copper and another one is steel. When you increase the temperature, okay, copper increases gradually with respect to time, that means it increases in with less time. Okay, steel not increases that much amount of volume expansion in this time. So copper is bend with convex side. Okay, why? Because alpha of copper is greater than alpha of steel. You have to know this. And if the temperature of a uniform rod is slightly increased by del T, its moment of inertia I about a perpendicular bisector increases by, let's say 2 alpha I del T. If it is parallel, that is 0. Okay, and the next one, the temperature of water at the surface of a deep lake is 2 degrees centigrade. The temperature expected at the bottom, the temperature, that means the water density. Okay, water most density value is 3.98 degrees centigrade accurately. So here 3.98 degrees nearly equals to 4 degrees. So this is the right option. And an aluminum sphere is dipped into water at 10 degrees centigrade. Up to 20 degrees centigrade, anything can't be changed with respect to the shape. So at 10 degrees, if the temperature is increased, that means when T is increased, okay, density of water gets increased. Okay, density of density of water gets decreased. Why? Because from this 11th question, density of water, okay, density of water is directly proportional to buoyant force, but it is inversely proportional to temperature. So that this is the relation between them. You have to learn about the theory, then find out the question. Okay, so in case of 9, okay, parallel, it is 0. In case of 8, that is in case of perpendicular, y 2 alpha L 2 alpha I dt. I said it definitely. Just so from this one, you know about moment of inertia value. Okay, what you know about moment of inertia value? ml square by 12. Okay, so ml square by 12 is the moment of inertia value. So that change in moment of inertia gives you d by dt of ml square, d by dl of ml square by 12. Okay, so that gives you the option. I explained in comment section what is it to be. Okay, please see comment section for more information about this. Okay, thank you.